CSEC Multiple Choice Practice Paper 1B has the solution of the second 15 problems of CSEC Practice Paper 1, that is CSEC Multiple Choice Practice Paper 1. So we will now present the solution of problems from 16 to 30. In the triangle that we have right here, BC is 10 centimeters as we have it right here. Angle BAC is equal to 90 degrees, which of course is a right angle triangle. So we need to have a right angle in here, and this is the right angle. And we have another angle right here, 37 degrees, that is angle ACB. And we need to determine the length of AC in centimeters. The triangle is right angled as we have stated before and requires only an application of the basic trig ratios. That is, if we have a right angled triangle, the trig ratios in their pure form, sine, cosine, and tangent, are applicable. We find that Pythagoras' theorem is also applicable to right angled triangles. But in this particular case, we will solve the problem according to the information that we have right there already. We need to find the length of AC. This will be done while considering the knowns. So we are going to find the length of AC, but that will be done by considering the information that we have, or the known side and the known angle that we have already. And what are they? This 37 degrees angle and this 10 centimeters. AC is adjacent to the 37 degrees angle. So this is AC and it is adjacent to the 37 degrees angle. The known side, which is 10 centimeters, is the hypotenuse. And here we have the hypotenuse and an arrow going from the right angle to the hypotenuse, in accordance with what we have in Richard James Mathematics Resources, explaining that the hypotenuse is the longest side of the right angle triangle and it is opposite to the right angle. And that is why we have this arrow going like that, demonstrating that the hypotenuse is opposite to the right angle. The trig ratio that makes use of adjacent and hypotenuse is cosine. Cosine is equal to adjacent over hypotenuse. So we are talking about this side that is adjacent to the angle, and we are also concerned with the hypotenuse. So we need to determine the trig ratio and make use of it. The trig ratio, of course, that makes use of hypotenuse and adjacent, and that one is cosine. But that is not sufficient. We also need to know that what? Cosine is equal to adjacent over hypotenuse. So cos of 37 is equal to adjacent over hypotenuse. Substitute the appropriate values. So we are going to substitute the value for the adjacent if we have that, and also for the hypotenuse if we have that. So cos 37 is equal to AC over 10. By transposition, this is what we get. So we have cos 37 is equal to AC over 10. Multiplying both sides by 10 in order to get rid of this 10 that we are dividing by on the right hand side. 10 will be eliminated from this side, and of course we'll have 10 being multiplied on the left hand side, and that is going to be as a consequence of multiplying both sides by 10. So we have 10 cos 37 is equal to AC, and of course we like to put the subject of the formula on the left hand side, so we have AC is equal to 10 cos 37, and of course that is our correct answer. Candidates that are sharp on their trig ratios we'll know that the adjacent is equal to the hypotenuse multiplied by the cos of the angle, and that the hypotenuse is equal to the adjacent divided by cos of the angle when the appropriate side and angle are given. So if you are sharp on your trigs, the adjacent is what we need to find. We always know that in order to find the adjacent, we multiply the hypotenuse by cos of the angle. And of course, if we had the adjacent given and we need to find the hypotenuse, then we know that the hypotenuse is equal to the adjacent divided by cosine of the angle. And we can make use of that when we are out of time or when we are solving problems, as we are solving problems in multiple choice, which requires that we apply our principles in a short period of time. Which of the following sets represent the relation f such that x maps to x squared plus 3? The content of each pair of brackets is called an ordered pair. So we are just looking at the definition of some of these terms that we are going to be using, or at least explaining what the devices are, giving names to them, so that in the long run we can say that we know what these are called. So the contents of each bracket is called an ordered pair. And of course we have a lot of them right here enclosed in braces. The entire set is called a set of ordered pairs. So each one of these represents a set of ordered pairs. In all of the options, all of the first numbers are the same. So notice that the first number in the ordered pair, 0 here, 1 there, this we have 2, right? So this is because they represent mappings in which the domain, or what we call the first set, is the same in all cases, and that we are demonstrating right here. Right, so we know, or we are demonstrating, that each option represents a mapping, of course, in which the first set, notice that the first set here is the same in all cases, and that is why we have the first number in each pair, as we have them right here. The first numbers are all equal. So the mapping, each one of these is representing a mapping from a domain that is the same in every single case. So for clarification, we have expressed each ordered pair as a mapping. So for clarification, we are showing that each set of ordered pairs may be written as a mapping. And of course we have these mappings right here. In an examination, I imagine that the examiner will consider it unfair for a candidate to examine all 16 pairs in order to determine the correct answer. This will take too long. The most logical answer is therefore option A. So, in order to determine which one of these represent this mapping, without being strategic about it, candidates might want to check each one of these, then they come and check all of these, all the way down, until they are able to identify the correct answer. And of course, doing that for every single one is going to be very time consuming because we have 16 of them. So based on that fact, it is just a harsh guess that I'm making that A is the correct answer. However, choosing an answer for the reason mentioned on the previous slide is just not valid. it is not a valid enough reason for choosing an answer in a multiple choice examination. By examining all of the answers, the second numbers, that is, we realize that in option A, 12 is the unique result of the fourth pair. So examining all of those, we realize that in option A, 12 is unique, is a unique answer we have right here for the fourth pairs. So all of these fourth pairs we are looking at, and we see that 12 is unique. Of course, 6 is another unique answer, but 12 is unique. Right. If we substitute 3 into the expression and the result is 12, then we have solved the problem by examining only one pair. So we have f of 3 is equal to 3 squared plus 3. See, x is mapped to x squared plus 3. So if x is equal to 3, we have 3 squared plus 3. And when we work that out, 3 squared is 9, so 9 plus 3 is equal to 12. And there we have it. So there we have shown that the correct answer is actually option A, just by making only one of 16 possible examination. So by just examining a single pair, we have discovered that the answer is A. The first method is not ideal, but in the event that any such problem appears when we have only 1 second left, it might result in you obtaining an extra mark. That is, by saying that the examiner is thinking that this is just too much work to be done in a multiple choice examination. So we'll just cause the answer to be A so that the student does not waste much time. Well, does not waste much time if he's taking a correct approach to the problem. That method, that is the first one, just to guess it like that, is not very good. But in the case that we are just flying through the ones that we have not answered in the time allotted, and we need to make very intelligent guesses in a short period of time, then that might be a very intelligent way to guess an answer. And as a matter of fact, it would have been correct, and we would have received that single mark. Well, a single mark is not very important, you might think, but on the border, when we have border results, then 1 mark is very, very important. So the first method is not ideal, but in the event that any such problem appears when we have only 1 second left, it may result in you obtaining an extra mark. Let us say 12 failed to prove that option A is correct. Now we have singled out this one because of its uniqueness, and we have said, okay, then let us see if it works, and we got 12. Because for sure it is 12, then we are sure that this one is the correct answer, because we do not have a 12 and a 12 here. And as long as 12 is correct, then A is correct. So let us say 12 failed to prove that option A is correct. Now further, let us assume that the result is actually 9. Since there are 2 pairs that result in 9, we would have to check another pair in one or both of the relevant options in order to be guaranteed an identification of the correct answer. So what we are saying is that if we are looking at 9, then say 9 is correct, we have 1 pair with 9 here and 1 pair with 9 right here. So we cannot be sure which one is correct. Therefore, we would have to check this one. And if this one proves to be incorrect, then we know that the answer is this one. But if this one is correct, then we are sure that the option is B. So if we had 9 here, then we would have to check another pair, and that is all that is necessary. So in this event, we would have to check at most 2 pairs, and that will have to do in order to be guaranteed an identification of the correct answer. In any event, we realize that the correct answer may be identified by making very few of the possible calculations. So if we are using our common sense, we will never ever have to check all 16 of them. As a matter of fact, we can even check just a single one in order that we are guaranteed an identification of the correct answer. And of course, in this particular case, if that fails, we might need to check just another pair, and that would suffice. Now, if p minus 3 is the largest of 4 consecutive odd numbers, then the smallest is, that is what we need to determine. P minus 3 is the largest one. Which one is the smallest? The first fact that is worthy of note in the problem is that the problem did not say consecutive numbers, but consecutive odd numbers. Since odd and even numbers alternate, the difference between consecutive numbers is not 1 but 2. So the difference between consecutive odd numbers is 2, and the difference between consecutive even numbers is 2. So we are not saying consecutive numbers, we are saying consecutive odd numbers. So the difference between the two of them, or 2 consecutive odd numbers, is 2. So we need to pay attention now to one more important detail. Another fact that is noteworthy is that p minus 3 is the largest. Since p minus 3 is the largest, the other numbers are smaller. We know that the larger the number that we subtract from any number, an unknown number, say p, not excluded, the smaller the result. So we are saying that the larger the number that we subtract from another number is the smaller the result will be. Okay. We may therefore subtract 2 from p minus 3 each time until we arrive at the smallest number. So p minus 3 is the largest. So to go smaller, we need to subtract 2. Remember that the difference between consecutive odd numbers is 2. So we are going to subtract 2. So we have the fourth, which is the largest number, is p minus 3. From that we are going to subtract 2. So p minus 3 minus 2. And what do we know? Do not forget that when we are adding numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added. So we are subtracting 3 and subtracting 2. So consequently we are subtracting 5. So p minus 5. So when we are adding numbers that have the same sign, we are going to just add the values and then the answer will take the same sign as the numbers that we have added. So we have that third number is p minus 5. So the fourth is p minus 3 and the third is p minus 5, and we can see a pattern developing. But not good to say that we can conclude on a pattern unless we have 3 terms. So we have another one. So p minus 5. So p minus 5 and we are subtracting another 2. Okay? So we are subtracting 2 again. As a matter of fact, our argument is that this one is the largest. So if we want a smaller number, we have to subtract and subtract and subtract. But because we are talking about consecutive odd numbers, we are subtracting 2 each time. So now we have p minus 7, and that is your second number. And of course, we have p minus 3, p minus 5, p minus 7. Notice that the number that we are subtracting is increasing by 2 each time. Following the trend, we may write down the smallest number. So we are going to follow this trend: p minus 3, p minus 5, p minus 7, then we have p minus 9. Therefore, we can conclude that the correct option is B, p minus 9. 1, 2, 3, 4 consecutive odd numbers. All of the other options represent good distractors, in that A is the result of subtracting 2 4 times. So we have what? Consecutive. We say this is the largest of what? 4 consecutive odd numbers. So we have p minus 11. And that is what we will get if we subtract 2 4 times. Although this would have resulted in 5 consecutive numbers, it is quite likely that a candidate could have made such a mistake. So a candidate may say that since it is the largest of 4 consecutive odd numbers, let us subtract 4 times 2, which is 8. So it will be p minus 3 minus 8, we get p minus 11. And that is how this one, A, is a good enough distractor. C is the result obtained by adding 2 each time rather than subtracting 2 each time. It is not far-fetched that a candidate would choose this option. This one and the option D would have been easily eliminated by a candidate who is quite aware that if p minus 3 is the largest, then p plus 3 and p plus 5 are impossible, since they are both larger than p minus 3. And of course, they are good distractors because sometimes students need to go in a particular direction in solving a problem, and because of the way that the problem is stated and their interpretation of the problem, they go in the opposite direction. So by going in the opposite direction, one may want to say 4 times 2 is 8, and we are going to add 8 to p minus 3. When add 8 to p minus 3, what do we get? P plus 5. On the other hand, the other one might want to take an approach that is similar to this, but instead of subtracting 2 each time, the person adds, or the candidate adds 2 each time, and that will be the result, p plus 3. So they are good distractors. It is not impossible for candidates to imagine that 4 consecutive odd numbers will imply that we need to add 4 times 2 to p minus 3. Right, so we are focusing heavily on the 4, and because we are saying 4, we have this tendency to add 4 times 2 to p minus 3. And of course, the answer for such a mistake is there. I would have preferred if one of the distractors suggests that some candidate would have ignored the fact consecutive odd. So if candidates ignore this fact, then they will have other answers coming. And I was looking for a distractor inside of the set of options. I imagine then you cannot have all of the possible distractors, but I was thinking that we could have had a distractor in which the candidate did not take careful note that it should have been what? Consecutive odd numbers, and then start to interpret the problem as consecutive numbers. Right, so if that is the case, then possible distractors could have been what? P minus 3, P minus 7, and P plus 1. But of course, they are not there, and there's no harm done. Candidates who are sure about what they are doing are not easily distracted by any sort of concoction that might be present in the other options. In a multiple choice examination, we do not have a lot of time allotted for answering each question. Some candidates may be aware of the important facts very quickly and proceed to subtract 2 each time, arriving at the answer in a matter of seconds. This is what is expected of someone with the correct interpretation of the problem. So subtracting 2 each time, you'll just arrive at your answer in a matter of seconds, and that is what is expected of someone who has the correct interpretation of the problem. The only danger in subtracting 2 one time too many and ending up with p minus 11 rather than p minus 9. So the only danger is subtracting 2 one time too many and ending up with p minus 11 rather than p minus 9. The most likely way for such a malady to occur is not by actually writing down the numbers as we have just done, subtracting 2 each time, as this method will cause the candidate to actually see the 4 numbers being generated. So some candidates may want to subtract 2 one time too many and end up with p minus 11. And of course, the method that we have just used is one that is going to guard against such an occurrence. The mistake is most likely for those candidates whose interpretation of the problem is heavily hinged on the number 4, to the extent that they multiply 2 by 4 and subtract 8 from p minus 3. So by writing down the numbers, we will see 4 numbers, and then we'll know that if p minus 3 is the largest, then p minus 9 is the smallest of the 3 consecutive odd numbers. Right. But for candidates who are thinking about the 4 more than anything else, they might want to say 2 multiplied by 4, because we know that the difference between 2 consecutive odd numbers is 2. So they say 2 multiplied by 4 is 8. And from p minus 3, they subtract 8. And what is the result? P minus 11, which is one of the options. And they are sure, but the answer will be incorrect. Candidates need to understand that in counting, there are inclusive and exclusive reckoning. Of course, we have a lot of other reckonings, right? But in counting, we have 2 main reckonings. One is inclusive and the other is exclusive reckoning. It is inclusive reckoning that is applicable in this case. Why? Because p minus 3 is one of them. So because p minus 3 is one of them, it has to be included. So that is why we have inclusive reckoning. P minus 3 is the largest of 4 consecutive odd numbers. So p minus 3 is included in this set of numbers. So we have inclusive reckoning. So it is inclusive reckoning that is applicable in this case. When using inclusive reckoning, the number that we should use in our calculation is usually 1 less than the number suggested in the statement of the problem. And what is the number that is suggested in the statement of the problem? 4. The largest of how many consecutive numbers? 4. So 4 is the number that is used. Right. So because it is inclusive reckoning, the number that we are going to use should be 1 less than the number that is suggested in the statement of the problem. So instead of using 4, we use 3. Therefore, instead of subtracting 4 times 2, we subtract 3 times 2. So inclusive reckoning, we use 1 less. So instead of 4, we say 3. And of course, understanding that inclusive reckoning, the students will have no problem arriving at the correct answer, even if he did not choose to write down each one of the numbers as we have done. A circular wheel has radius 14 centimeters. How far will it travel in 10 revolutions? Of course, that's a very nice problem and has practical applications. Right, you need to know how far the wheel will travel in 10 revolutions. When a wheel is rolling, the distance that it travels is equal to its circumference. The answer that we are seeking is therefore 10 times the circumference of the wheel. The formula for circumference is equal to 2 pi r. 2 multiplied by pi multiplied by r. R is the radius of the circle. Pi is equal to 22 over 7 or 3.14. We are going to use 22 over 7 in this particular case. So substituting the values, where we see pi we put 22 over 7, and when we see r we put the radius of the wheel, which is 14 centimeters. So we have c is equal to 2 times 22 over 7 multiplied by 14. And what do? Reduce the expression by a common factor of 7. Will cause 7 to be eliminated from the denominator. And of course we know that 14 divided by 7 is 2. So 7 is eliminated and 7 into 14 is 2. So we will have 2 times 2. 2 times 22 times 2. So 2 multiplied by 22 multiplied by 2, and that is equal to 88 centimeters. Do not forget that we need 10 revolutions. So we multiply by 10 for 10 revolutions. The distance that the wheel will travel is 880 centimeters, multiplying the circumference of the wheel by 10. .440 centimeters would have been a serious distraction for candidates who left the 2 out of the formula of the circumference. I would have liked to see a distraction targeting those candidates who are susceptible to using the formula for the area of the circle instead. So some candidates might leave off the 2 here, and their result will be, of course, this, and the answer is there for such an occurrence. But I would have liked to see a distraction that is targeting those students or those candidates who are tempted to use the formula for the area of the circle instead. Classes in a school start at 8:50 hours and end at 1500 hours. There's a 20 minutes morning break and a midday break of 1 hour. How much time is spent in class? One of the most efficient ways of solving this problem is to subtract the beginning time from the end time. Then, of course, going straight ahead to subtract the total time of the breaks. So we are going to subtract the beginning time from the end time, and then go straight ahead to subtract the total time for the breaks, and we will get the answer, no doubt. So we have the beginning time and the end time. So we are going to subtract. The beginning time is what? 8:50 hours, and the end is 1500 hours. 50 minutes, we are going to subtract 50 minutes from this, which is 0 minute. We cannot do that, so we go to the hour side and rename the 15 hours to 14 hours. The 1 hour will be transferred to the minute side as 60 minutes. 60 minutes equal 1 hour. So 14 there and 60 there, and we are comfortable subtracting 50 from 60, and we get 10. So we have 10 minutes right there. Then we say 8 from 14, and that is equal to 6. So we have 6 hours and 10 minutes. This is exactly equal to one of your distractors. Yeah, we have the answer right there for that. So some students who imagine that they have solved the problem already, they would have seen an option that is catering for their mistake, right? And they would have gone to the next problem, not realizing or not remembering to subtract the time for the break. So now let us subtract the total time of the breaks, and we know that we have a 20-minute break and an hour break, so we are going to subtract from this time the time for the break, and we are going to say 20 minutes to be subtracted from 10, and that is not possible. So we go to the hour side and rename 6. The 1 hour will be transferred again to the minute side as 60 minutes. It will be combined with the 10 minutes already there to give 70 minutes. So we have 10 minutes there already. So renaming, we have 5 hours left, and the 1 hour to this side will be 60 minutes. So we have 60 and 10 is already there. We have a total of 70 minutes, from which we are going to subtract 20, 50. So we have our 50 minutes right there. And 1 from 5 is 4. Good. So there we have our correct answer. Option B, 4 hours and 50 minutes. The problem could have easily been solved mentally. Just do not forget to subtract the time of the breaks. So we're going to take a mental approach to the solution of the problem. Let us take a mental shot at this problem. In steps, of course, from 8:50 to 9 o'clock. So from 8:50 to 900 hours is 10 minutes. Okay, so we have 10 minutes right there. From 900 hours to 1500 hours is 6 hours. So we have from 8:50 to 9 is 10 minutes, and from 9 to 15 is 6 hours. So we have what? 6 hours and 10 minutes. Subtract 1 hour from 6 hours and 10 minutes, and that gives us 5 hours and 10 minutes. So we are subtracting the breaks, right? So we subtract the 1 hour break first. We get 5 hours and 10 minutes. Then we will finally take 20 minutes from 5 hours and 10 minutes. And that will leave us with 4 hours and 50 minutes. And the problem is solved. Some candidates may want to play it safe and subtract the 20 minutes at the end, 10 minutes at a time. 10 minutes from 5 hours and 10 minutes leave us with 5 hours. And of course, we have another 10 minutes to subtract. So from that 5 hours, we will subtract 10 minutes. And what do we have left? 10 minutes from 5 hours, we have 4 hours and 50 minutes. The original price of an article was $240. The price is increased by 12.5%. The new price of the article is... Let's see how we'll solve that problem. In solving this problem, the examiners imagined that the candidates are aware that 12.5% is equal to 1/8. Therefore, if we are increasing by 12.5%, we are increasing $240 by 1/8. In so doing, we are going to add 1/8 of $240 to $240. So 1/8 of 240, no problem seeing that 8 into 24 is 3. We will have 8 into 240, that is equal to 30. So reducing the expression by a common factor of 8 will cause 8 to be eliminated from the denominator, and 240 divided by 8 is equal to 30. So we have $30. So we are going to be increasing the original by $30. And what do we know? 240 plus 30 is $270, and that is option D. This could have been done in a few seconds by considering that 12.5% is 1/8, and also that 240 is a multiple of 8. So 240 divided by 8 is 30, and then 240 plus 30 is 270. So if we could just see that immediately, we know that 12.5% is 1/8, and of course we realize that 240 is a multiple of 8. So if we see that, we have no problem solving the problem very quickly. 8 into 240, 30. And then we just add the 30 to the 240, and that will give us 270. Failure to make use of the knowledge or being unaware of the facts may result in one having to use a long process in arriving at the answer. That we will take a look at on the next slide. So if we do not make use of the knowledge, or we are just unaware of the facts, we will see how long and lengthy the solution of the problem can actually turn out to be. Let us convert the mixed number percentage to an improper fraction. So we have the mixed number percentage, and we are going to convert that to an improper fraction. Of course, we have the whole number, we have the numerator, and we have the denominator. Multiply the denominator. That is how we are going to convert it to an improper fraction. Multiply the denominator by the whole number, then add the result to the numerator. So 2 times 12, 24. Then we have 24 plus 1 is 25. The result is the numerator of the improper fraction. So 25 is what we get. And of course, the denominator is the same as before. A percentage is a fraction whose denominator is 100. So this is a percentage, so we need to divide this by 100. So 25 over 2 to be divided by 100, and that is easily simplified. By dividing by 2, then by 100, is equivalent to dividing by 200. So we have instead 25 over 200. The fraction will be multiplied by 240. Right. And of course, we are already seeing how horrible the situation that we find ourselves in is by being unaware of, or just not making use of, the facts that we have. So reduce by a common factor of 25. So we have 25 here. We are going to say 25 into 25 and 25 into 200. And what do you know? We are back with our original 1/8. Remember that we say that 12.5% is equal to 1/8. So we have that 1/8 right there that we had earlier on. And of course, 8 into 240 as before is equal to 30. So we are going to be reducing by a common factor of 8 as we have done before. And now we have our 30. Eventually, we have our 30. And add 30 to 240, and we end up with 270. And we would have just arrived after so many years at the correct answer. All of this may have been prevented by being sharp on your digits. Students who are not sharp usually discover to their horror that they may not use a calculator in a multiple choice exam. So some students, they are horrified that they cannot use a calculator in a multiple choice examination. But such is the case. Students, candidates need to be very sharp and to be numerically efficient. If the number x is such that 60 is less than x is less than 80, that means x is between 60 and 80. Then, between which two numbers lies the square root of x? So we have 60 is less than x is less than 80. Between which two numbers lies the square root of x? And even for me, this is a challenging problem. Alright, so what do? We go straight ahead and eliminate two of the impossible answers. So two of the answers may be easily eliminated because any number that is between 7 and 8 is also between 7 and 9. So we're going to take this one out because any number that is between 7 and 8 is also between 7 and 9. So this one is eliminated. Also, any number that is between 8 and 9 is also between 8 and 10. And this will eliminate option C. Right. So if a number is between 8 and 9, that number is sure to be between 8 and 10. So we may take that one out also. And we have only two options to wrestle with. Let us take a look at the square of the two numbers of option B against the condition that we have. So we have the two numbers in option B, 7 and 9. We have them squared right here. And we are going to say that the number x is between 60 and 80. Okay? And why are we squaring? Because we are looking for the number between which lies the square root of x. So if the square root of x lies between, say, 7 and 9, then x will lie between the square of these two numbers, say. Okay? So we are talking about the square root of x lying between 7 and 9. So to find the two numbers that x will lie between, we will have to find the square of those two numbers. So we square 7 and we square 9, and we are measuring that against the condition that we have right here. We are replacing or repeating that condition right here also. So square 7 we get 49, square 9 we get 81. Of course, what do we know? 60 and 80, they both lie between the two resulting numbers. So 60 is between 49 and 81, and 80 is between 49 and 81. So we are sure that any number that is between 60 and 80 must therefore be between those two numbers, and option B is correct. So any number that lies between 60 and 80 will also lie between 49 and 81. Therefore, these numbers that we have here in option B causes that option to be correct. The number is between 60 and 80 for sure, and for sure 60 and 80 is between 49 and 81. So option B is correct. However, let us verify that option D is incorrect by the same process, and we are measuring the square of the numbers in option D against the original condition that we have right there. 8 squared is 64. 10 squared is 100. Is 60 between 64 and 100? No, although 80 is. So they are not both between 64 and 100. So 60 and 80 do not both lie between the two resulting numbers. A number that is between 60 and 80 is not necessarily between those two numbers. So option D cannot be correct. So x is between 60 and 80. Therefore, we are sure in this particular case that x is between 49 and 81. That's correct. But in this particular case, 60 is not between 64 and 100. Therefore, we are sure that option D cannot be correct. The prices of all goods in a store were marked up by 20%. During a sale, a 20% discount on marked prices was given. How did the final prices compare with the prices before the markup? They were the same. The final was more than the original. The final was less than the original. And of course, we have the one that is the favorite of all the students. Enough information was not given to decide. But I beg to differ. Let us first do a little refresher on increasing and decreasing by a given percentage. The original is 100%. If we increase by 20%, it becomes 120%. Recall that a percentage is a fraction whose denominator is 100. 120% is actually 120 divided by 100, and that gives 1.2. Therefore, increasing by 20% may be achieved by multiplying the original by 1.2. Conversely, decreasing by 20% will cause the original to be reduced to 80%. 80 divided by 100 is 0.8. Decreasing a figure by 20% is the same as multiplying by 0.8. Let us say that the original price is x. We will increase x by 20%. How are we going to do that? By multiplying by 1.2. So x multiplied by 1.2 is 1.2x. Do not forget, increasing by 20% will cause the original to be increased to 120%. 120 divided by 100. That is what 120% is. 120 divided by 100. That is going to give us 1.2. So increasing x by 20% is the same as multiplying x by 1.2. So 1.2 times x is no doubt 1.2x. That's what we are using. That is what we have for our answer. Let us now decrease that 1.2x by 20%. Multiplying by 0.8. That is how we decrease a particular figure by 20%. We take 20 from 100 and we get 80. 80% is actually 80 divided by 100, and that will give us 0.8. So we are going to decrease now by 20%, and that is achieved by multiplying what we have there, this new result, by 0.8. So 1.2x multiplied by 0.8 is equal to 0.96x. That's what we have. Notice that the final answer is less than the original, as 0.96x is less than x. Of course, 0.96 is less than 1. So 0.96x is less than 1x, or less than the original. Therefore, the final answer is less than the original. Option C is correct. The final was less than the original. Good. if we decreased by 20%, then increased by 20%, the final result would have been the same, and the final still less than the original. So then, whether we increase by 20%, then decrease by 20%, or the other way around, the answer will be the same. Why? This is because multiplication is commutative. Multiplying by 1.2 then by 0.8 will yield the same result as multiplying by 0.8 then by 1.2. So multiplication is commutative. It does not matter which one you multiply first, the result is going to be the same. So whether we increase first then decrease, or we decrease then increase, the result will be the same. And it's going to be what? The final less than the original. Without making any calculation, we could have used common sense to arrive at our answer. If we increase a number by 20%, it becomes larger, isn't it? It is larger because we have increased by 20%. No, 20% of that large number is larger than 20% of the original. So 20% of a larger number is larger than 20% of a smaller number. The original was increased, therefore the new number is larger, and 20% of that larger number is greater than 20% of the original. Right. When we decrease the new number, which is the large one, by 20%, we are actually subtracting a larger number than we have added. Is that right? Of course it is right. It is correct because we are subtracting a larger number from the number that we have right there. Because in the end we are subtracting a larger number, the resulting number will therefore be smaller. So we have increased by 20%, making the number larger. Then the large number we are going to decrease by 20%. 20% of that larger number is larger. Therefore we are subtracting a larger number than we have added. Therefore the result is going to be smaller. Let us take a look at what happens if we were to reduce by 20% first. So if we reduce by 20% first, the number becomes smaller. 20% of that smaller number is smaller than 20% of the original. When we increase that number by 20%, that is the new number, when we increase that new number by 20%, we are adding a smaller number than we have subtracted. So if we are adding a smaller number than we have subtracted, the new number will still be smaller than the original. So we could have used our common sense and arrived at the answer. And the final will still be less than the original, irrespective of how we have progressed. A die was tossed 10 times, and the results are shown in the table. The median score is? The median is the middle item in a sorted list. When there is an even number of entries, the median is the average or the mean of the two middle numbers. That is, to find the median, when we have an even number of entries, we usually have two middle entries. So to find the median in that particular case, we add the two middle entries and divide by 2. So there are 10 entries. 10 divided by 2 is equal to 5. The two middle entries are the 5th and the 6th entries. The first temptation is to look at the already ordered list of scores and choose the two middle items. So here we have the scores 1, 2, 3, 4, 5, 6. So there's a temptation to take this list that we have right here that is already sorted and find the two middle numbers, 3 plus 4 divided by 2, and the result is 3.5. Luckily for us, that is not among the options, but that would have been an incorrect approach to the solution of the problem. We need to be aware of the fact that there are scores in the list that occur more than once. So we have like this score 2, its frequency is 4, telling us that 2 occurs 4 times. The number of times that those scores occur are determined by their frequencies. Our calculation must not be without taking that fact into account. So we need to take that fact into account that we have not just 1, 2, but we have 4, and of course here we are having 3 5s. Remember that the median will be the mean of the 5th and 6th entries. We are now in search of the 5th and 6th entries. At the end of the first column, we would have passed the first entry. So because we have a frequency of 1 right here, here we have a single entry. Right. Now we have a frequency of 4 right here. So we have inside this slot another 4 entries. Therefore, by the time we get to this point, we would have passed the 5th entry. So we have the first entry right here. Then we have 4 more. So we have the 2nd, the 3rd, the 4th, and the 5th entry right here. So the last entry in the next column, which is right here, is the 5th entry. Therefore, the first entry of the next column will be the 6th entry. So here we know that the 5th entry is the last one that we have right here, and then the 6th entry is the first one that we have in this one, but of course there's only one. So the 5th entry is a 2, and the 6th entry is a 3. So the 5th entry is a 2. Examine the corresponding scores. Of course, the entry is 2, and then the 6th entry is a 3. So the median is 2 plus 3 divided by 2. So the median is actually 2.5, and that is represented by option A. All candidates should be able to manipulate information in a frequency table, or to analyze them also. But if not, there is still hope. Let us use the table to write down all of the scores, then find the median. So, as indicated by the frequency row, some scores occur more than once. Let us use this fact along with the specific frequencies to write down all of the 10 scores. So we're going to write down all of the 10 scores, and we are going to use the fact that some of the scores occur more than once. So we have what there? There is only one 1. So 1 occurs once. We put it down. Then moving on, we have 4 2s. Now we have 4 2s. So there are the 4 of them. 1, 2, 3, 4 2s. And what do we know next? Right there we have only 1 3. So this one is telling us that the 3 is occurring only once. So we have a single 3 there. What do we have here? What do we have here? 4 is occurring 0 time? No time at all. So we do not have any 4. So we move merrily on to the 5s, and we have 3 of them. The frequency is 3, telling us that there are 3 5s. There we have them. 1, 2, 3. And then finally, we have a single 6. So we are finishing up with a single 6. There we have all of them now. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have all of the 10 scores that are suggested in the statement of the problem, and that is verified by the table and demonstrated by the list that we have right here. Let us now identify the 5th and the 6th entries. 1st, 2nd, 3rd, 4th, 5th, 6th. Right, so the 5th entry is a 2 and the 6th entry is a 3. The median may be found by adding the 2 middle entries and dividing the result by 2 as before. So 2 plus 3, of course, the 5th entry is a 2 and the 6th entry is a 3. Adding them and divide by 2, the result is 2.5 as before, right here. Now we need to find the mean of the scores. The mean is found by adding all of the entries and dividing the result by the number of entries. And what do you know? The first temptation is to look at the scores, find the sum of the values that we have there, and divide the result by 6, which is not correct. So we have 3.5 for our answer if we just add these up and divide by 6. Good for you that the answer is not among the options, because it is not correct. Do not forget, and of course you have not taken a correct approach, do not forget the fact that there are scores in the list that occur more than once. The number of times that those scores occur are determined by their frequencies. Our calculation must not be without taking that fact into account. Right. So there we have your frequency row with, of course, here and here we have what? Some scores occurring more than once. On top of that, we would have been neglecting a very important fact in the statement of the problem. That tells us that the die was tossed 10 times. So in dividing by 6, we are neglecting this fact. That means we are considering that the die was tossed only 6 times. But we say that the die is tossed 10 times in accordance with what we have there in the statement of the problem. So, by saying that we are dividing by 6 here is neglecting that fact. Therefore, we have to account for the sum of 10 entries, and we need to divide the result by 10. So in finding the mean, we need to have how many entries? 10. And we have to account for that in some way or the other. And we have to divide by 10 when we have found the sum of all of those entries. As indicated by the frequency row, some scores occur more than once. Let us use this fact along with the specific frequencies to find the sum of all of them. So there is only 1 1, and we are going to find the sum of those. So since there is only 1 1, we say 1 multiplied by 1. And of course we have 4 2's. So we say 4 2's. 4 multiplied by 2. And what do we know next? 3. We have 1 3. So 1 multiplied by 3. So if we have 4 2's, we can say 4 multiplied by 2. But we have 1 3, so we have 1 multiplied by 3. And we could have put 0 multiplied by 4, but because we know that it is immaterial, we do not have any product for 4. We have a product for 5 because we have 3 5's. And of course we put them in right there, 3 5's. And no doubt 1 6. 1 6. So we have 1 1, 4 2's, 1 3, 3 5's, and 1 6. And we need to find the sum of those, but let us of course find the value of each product first. So let us now calculate the products. We have what? 1 multiplied by 1 is 1, 4 multiplied by 2 is 8, 1 multiplied by 3 is 3, 3 times 5 is 15, and 1 multiplied by 6 is 6. No problem whatsoever. The sum is 33. Let us find the mean by dividing the result by 10. So the mean is 33 divided by 10, and the result is 3.3. Option C. The mean could have been found by making use of the frequency table or of a frequency table in writing down all of the 10 scores. Finding their sum, then dividing by 10, which is of course the number of scores. So we could have found the mean by making use of a frequency table. Of course we have a frequency table right there. So what do we know? There is only 1 1. So we have 4 2's. So what do we know? We have 4 2's right there. And we have 1 3. 1 3. Then we do not have any 4 at all. So we do not need to include 1. And we have 3 5's. So we are including those 5's. 3 of them in total. And we have that 1 6 right there. So 1 multiplied by 6 is 6. But of course we are not dealing with products right now, so we put that 1 6 down. And of course we could proceed by finding the sum of all of those numbers, which we know to be 33, or you could probably verify that by adding the numbers in that list. And we finish up by dividing 33 by 10. So the mean is 33 divided by 10, and that gives 3.3. The graph, that is what we are going to be using, which is a bar chart. It is showing the number of boys with a given number of books. The total number of books is, or we need to determine the total number of books. But we need to understand what it means by number of boys with a given number of books. The graph is telling us the number of boys that have a particular number of books. If 8 boys are associated with 5 books, we do not have it right here, but if 8 boys are associated with 5 books, this means that each of the 8 boys has 5 books. So each of the boys has 5 books, and that will make a total of 8 multiplied by 5, which is equal to 40 books. And we are going to take that into account when we are determining the number of books in total. So let us write down the product associated with each bar. So that is your first bar. So we have 5 boys, each has 1 book. So 1 book, 5 boys. So 5 boys each has 1 book. So we have 5 times 1. Then what do we have? 4 boys each has 2 books. Right, 4 2's. Then we have 7 boys, and each one has 3 books. So there we have number of boys is 7, and 7 boys each has 3 books. So 7 times 3, and 5 boys each has 4 books. So we have a product, no doubt, right there. So let us now calculate the products. So we are going to do that. 5 multiplied by 1 is 5, 4 2 is 8, 7 3 is 21, and 5 4 is 20. Finish up by adding the numbers. So 5 plus 8 plus 21 plus 20. And that turns out to be 54. So the total number of books is 54. The best way to view this problem is as one involving a variable x, which is the number of books. So the number of books is represented by the variable x, and we have associated frequencies, and that will be represented by the number of boys. The total number of books will be the sum of the product of f and x. So let us demonstrate that in a table. It is customary for us to complete the table, then make the calculations. But on this occasion, we will calculate the value of fx when completing the table. So in statistics in general, we generally complete the table and then we do all the calculations after, but we are not going to take that approach in this particular case. We are going to make the calculation each step of the way. So what do we have? We have 5 boys, 1 book. So we have the information right there, and then the product is 1 multiplied by 5, which is 5. Goes there. And then next we have x is equal to 2 and f is equal to 4. Fx is equal to 8. So here we have 4 boys, 2 books, and the product is 8. On the other occasion, on the next occasion, we have x is equal to 3, f is equal to 7, fx is 21. So we have right here number of books 3, number of boys 7, and the product is 21. And we finish up with number of books 4, and we have 5 boys each has 4 books. So the total number of books is 20. We do not need the mean, so we will not divide the sum of fx by the sum of f, which is what we do when we are finding the mean. All we need is the total number of books, and this is equal to the sum of the products fx. So we need to just add those, and the result is 54. No problem with that answer. A car presently valued at $12,000 depreciates at the rate of 10% per annum. What will be its value 1 year later? A candidate that is sharp on his digits will be able to work this out in a matter of seconds. Or should I say, determine the answer in a matter of seconds. So determine the answer rather than working out. In a multiple choice examination, it is highly recommended that a wide variety of methods be used in arriving at an answer without actually doing a lot of work. So in a multiple choice examination, we need to take steps or use strategies, methods, means to arrive at the answer, and that we might do without actually working it out. So to depreciate means to decrease in value. The rate of depreciation given is per annum, and the value is to be determined after 1 year. Therefore, the value $12,000 is required to be decreased by 10% only once. To decrease by 10% means that we are finding 90% of the original. Of course, the original is 100%. And we are going down by or depreciating by 10%. So going down, we are now at 90%. Therefore, we need to find 90% of the original. But what is 90%? 90% is 90 divided by 100, which is equal to 0.9. We therefore need to multiply 12,000 by 0.9. Forgetting about the zeros in the 12,000 and the decimal place in 0.9, we just multiply 12 by 9. After multiplying 12 by 9, we get 108. And there's your 108 represented right here. Right. So the value that looks like this, or the value that looks like 108, will tell us that we are at our correct answer. And of course, the one that looks like 108 is this one, so we are sure, which is 10,800, and that is our correct answer, represented by option A. No need to worry. Some of the options are similar, but they are not the same. The 3 first digit in the answer distinguishes it from the rest of them. So there's no need to worry that kind of look similar. We have these have similar appearances, but they are just similar, not the same. And the correct answer is clearly 10,800. An article which cost $1,424 may be purchased by depositing $560 and making monthly payments of $48. In how many months will complete payment be made? And that is your consumer arithmetic type problem. In mathematics and in the real world, the deposit is made at the beginning of purchase and is subtracted from the total amount. So 1,424 minus 560, and we have 864. Each monthly installment will be taken from the 864 that we have left after making the deposit. Or we may say that the remainder of 864 will be reduced by $48 each time. We therefore need to divide 864 by 48. So 864 divided by 48 is equal to 18, and that is option A. So, no problem with our consumer arithmetic. This is pretty much straightforward. The transformation which maps the triangle PQR onto P prime Q prime R prime in the diagram is, so this maps to this. What is that transformation? Is it an enlargement of scale factor -1? A reflection in the line y is equal to x? A rotation of 180 degrees through the origin? A glide reflection? Let's see how we can navigate, or may we say dally, our way through this problem. When CXC requests that we describe a transformation, full marks will not be awarded if all of the details of the transformation are not outlined. So we do not imagine that they will require us to make use of an option in which the details are not outlined. Description of transformation must have the following. Reflection must be stated with the relevant mirror line. So you cannot leave that detail out of a reflection. Rotation must be stated with the angle plus direction of rotation, and the center of rotation must also be included. Translation must be accompanied by the relevant vector of translation or any other detail that will describe the transformation fully. Size transformation must be described with the center and the scale factor. If not, we have not described those transformations. So measure our option against this necessary and sufficient information. We will eliminate option A very speedily because the center of enlargement is not given. Needless to say that if it were stated that the origin is the center, it would have been correct. So, of course, if the origin was stated as the center of enlargement with scale factor -1, it would have represented a possible correct answer. But it says enlargement, and we do not know where the center is. So we have to say goodbye to that option. Option D is also unacceptable because the details of the glide reflection are not given. And what is a glide reflection? A glide reflection is a composition in any order of a reflection and a translation. So, if a glide reflection is described, we need to know the mirror line concerned, and we need to know the vector or whatever device or description or method that may be used to describe that translation. But for the translation we need detail, and there is no doubt that for the reflection we need detail, and we have no such detail furnished to us, so we are sure already that D is incorrect. So if the details of glide reflection were given, the option still would not have been correct. We will take a look at two such possibilities. So the glide reflection details were not given, so we are sure that it is not correct. But let's say that details were given to the extent that we could use our common sense and arrive at a possible glide reflection. So what we are doing, we are taking the image by a glide reflection and matching it with the original, right? So which is somewhat reversing the process of the glide reflection. That's what we are doing. We are reversing the process of the glide reflection and see if we end up with the original. So we know that the glide reflection is not correct, and we are going to do two glide reflections, or the reverse of two glide reflections, and show that the image and the original would not have matched. So we translate and then we reflect. So we translate parallel to the x-axis and we reflect in the x-axis, and what do we know? That if we do the reverse process, we would still not end up with the original. Therefore, we are sure that that one is not correct. And of course, let's take a go at it again. Right, that one is not correct. That is the first. That is the one that we have shown. That is the first. Now let us take a look at the second. See that? Now we are translating parallel to the y-axis and reflecting in the y-axis. And what do we know? That we do not end up in our original position. Therefore, we know that for those two examples, the transformation is not a glide reflection. And of course, glide reflection cannot be correct in the option because details of the glide reflection were not supplied. In neither of the cases did the images match exactly. The first was a translation parallel to the x-axis followed by a reflection in the x-axis, and the second was parallel to the y-axis then a reflection in the y-axis, no glide reflection will work. So no matter what we do, glide reflection would have proven to be incorrect, and we have decided that it is incorrect already as an option because details of the glide reflection were not supplied. Let us take a look at a reflection in the line y is equal to x. Cannot do that if we do not have the line y is equal to x. So let us draw that line y is equal to x first. There we have it. The image of R must be located in such a way that the line joining it and its image is perpendicular to the mirror line. So we are going to draw a line from R to its image, and it must be perpendicular to the mirror line like that. Okay, right. Also, the point and its image are equal distance from the mirror line. This will cause the image of R to be at that location and the negative portion of the y-axis. So, equal distance from here will take us right there. And that is where the image of the point R would have been. But where is it in this particular diagram? Right here. So we are 100% sure that reflection in the line y is equal to x is not correct. It is therefore clear that option B is not correct, because when we carry out that transformation, we do not end up with R prime at the location that we have in this diagram. Also, reflection is one transformation in which the object and its image do not have the same orientation. Therefore, after a reflection, if the vertices of the object are named in a clockwise direction, naming the vertices of the image will take us in an anti-clockwise direction. So, if we had a reflection, let's look at it. P, Q, R. This is what? Anti-clockwise direction. P, Q, R. This is anti-clockwise. If this were a reflection, when we go down here and do P, Q, R, see, we are going still in an anti-clockwise direction. So P, Q, R is anti-clockwise here, and P, Q, R is anti-clockwise here. So because they are both anti-clockwise, we are 100% sure that the transformation is not a reflection, because if it were a reflection, the object and its image would have different orientation and the vertices would have been named in opposite direction. In this particular case, naming the points and their images will take us in the same direction as we have shown already. Because they are going in the same direction, we are sure that they have the same orientation, and the transformation cannot possibly be a reflection. So option B is definitely out. By process of elimination, option C is correct. Well, we don't have anything left. The angle is given, which is of course 180 degrees. And the point about which rotation takes place is also given, which is the origin. It is not necessary to say clockwise or anti-clockwise, because 180 degrees in any direction will cause the image to be located at the same spot. So 180 degrees, angle on a straight line. So if we go clockwise or anti-clockwise, we will end up at that same spot. My only reservation is the word through. I would have preferred the word about, and that would make the statement a rotation of 180 degrees about the origin. That minor discrepancy cannot cause the option to be incorrect, especially when the others are less correct than C. So because they are not if we may say as correct as C, then the minor discrepancy is not possible to eliminate C. So C is the correct answer. Irrespective of my preference, I would prefer about, but they say through. The transformations represented by a rotation through 180 degrees about the origin and a size transformation of scale factor -1 that is centered at the origin are equivalent. So if we use an enlargement of scale factor -1 and had it centered at the origin, it would give us the same result as a rotation of 180 degrees about the origin. They are equal. However, in option A, the center was not stated. Because the center was not stated, we cannot be sure and we cannot jump to any conclusion that it is actually at the origin. Jumping to conclusion is bad exercise. The problem requires the transposition of the formula. The problem requires that we transpose this formula, making V the subject. So we are going to transpose and make V the subject of the formula. Half on the right hand side means that we are actually dividing by 2. We will transpose that 2 by multiplying by 2 on the left hand side. Or we may say we will eliminate the 2 from this side where we have the V, because we need to eliminate everything from that side apart from the V. So we will eliminate this 2 by multiplying by 2 on both sides. By multiplying by 2 on both sides, the 2 will cancel, eliminating the 2 altogether from the right hand side. And of course, the left hand side being multiplied by 2 will be 2 times E. We need V all by itself on the right hand side, but it is multiplied by M. M will be transposed to the left hand side by division. So there we have it. We are multiplying by M here. So what do? We need to get rid of this M or eliminate this M by dividing by M, because we are multiplying by M. So we divide by M here. So what we are doing is actually dividing by M on both sides. The M's on this side will cancel, and we will have 2E over M as we have it right here. So our next step is to eliminate this square. V is already by itself, but it is squared. We may eliminate the square by finding the square root of both sides. This will result in the square root of the left hand side, and the inverse operations on the right hand side will cancel each other. So we will find the square root of V squared, and we'll find the square root of 2E over M. The square root and the square will have a cancelling effect on each other. They are inverse operations, so they will have the effect of cancelling each other, and V will be left on the right hand side. The square root of 2E over M will remain on the left hand side, as we have it right there. It is not proper to leave the subject on the right hand side. The expression will therefore be reversed, and we will reverse the expression. V is equal to the square root of 2E over M, and no doubt is represented by option C.